Hey everyone, it's John, and today I'm going to do another video on BGP. This is going to be the second part of my BGP video series, and in the last one we discussed the path attributes, weight and local preference. So if we look at the right hand side here, I've actually listed the BGP best path algorithm, save for a few tiebreakers which I've excluded here. But the last video discussed weight, which is the most influential, the strongest path attribute, followed by local preference. Now, weight only affects the router locally, and the local preference is effective throughout the AS. The one which we're going to focus on today is AS path. Now, what is AS path? AS path is effectively the chain of autonomous systems through which a prefix traverses when it's advertised. So, for example, here in the topology, we've got an AS here, AS5. It's going to act like a kind of local AS which we kind of control. We've got an ISP here, and we've also got these ASs here, AS44, AS66 and AS23. Now AS23 is going to advertise a loopback 0 of address 23.23.23.23/32, and that's going to be injected into BGP. Now the AS path that it's going to take from the point of view of these routers here, it's going to go from here to here to here to here, and here, 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 here. Now, because the weight, from the point of view here, the weight is not being changed, it's all default, the local preference is still the same, and the local injection is still the same. The AS path is going to be the tiebreaker here, because if we actually look at the topology, there actually is a bit of an asymmetry to the network, because we have this missing link here, which means that going through the top route over here, you're actually only traversing 3 different autonomous systems. We're going through 100, we're going through 44 and 23, 1, 2, 3. If we go the bottom route, the AS path is actually going through 4 autonomous systems. We're going through AS 100, 66, up to 44, and then 23, which is 1, 2, 3, 4. So because of that, the tie break effectively, as deduced by BGP, is going to say that we're going to go the shortest, the lower AS path, which is over here. Now I must say it's not actually contingent, even though to look at this visually, you might be thinking this is like RIP and it's just a question of just hop count. Now the way this is done, it's on a smaller scale. For example, AS44 could have a bunch of routers here. I've just demonstrated it using one router. This could have 10 routers, this could have 2 routers, it doesn't matter, it's actually the AS path, it's not the amount of routers in the AS through which it traverses, so just keep that in mind. So what we're going to do here is we're going to inject this route into BGP, and it's going to be here available to us now. Now the path we're going to take to get there, like I said, is going to go through this top router in the ISP. We're going to configure the AS path from the point of view of, we're going to act like the ISP first, and the ISP is just going to say, do you know what, we would rather have the traffic come through this link here. That's what we want. We're trying to influence to say we would prefer it through here. So how would we do that? Because the last video we did was weight and local preference. Now think about that. Weight was only local to the router, and local preference was only local to that AS. So how are we as an ISP going to affect change in a different autonomous system? Because we can't use local preference. We can't just say local preference 200 out and try to advertise it out here, because it's not going to have any effect in AS5 when it's sent from AS 100. Now AS path is actually an attribute which can be transitive and go through different autonomous systems. That's actually one of the key functions of using AS path. So what we're going to do is use a technique called AS path prepending. Now the main one of the big features of eBGP particularly is well, really eBGP, because iBGP doesn't have this issue. eBGP maps the ASs through which it traverses, and it uses that as a loop prevention mechanism. So for example, if you had to conceptualize it as, think of the tag, the AS tag, imagine it was like a passport, right? So if you get on a plane in France and you're stamped at the airport at the French customs, you get the stamps when you've been in France, then you get a flight to Germany. Now the Germans stamp it, so you've been in Germany, then you get a flight to Italy and the Italians stamp it, and then you get a flight back to France, and the people at the French customs see you've already been stamped with France, so they can deduce from that that you're actually looped right round, you've came right back. Effectively, that's roughly what's happening with eBGP. It's looking at the ES path, and if it's going from 100, 44, 66, 23, and if it goes back to the same AS, it can detect that it's a loop. Now, so it's consistently adding on these tags, so that's what you see. So for example, if we look at the path here, BGP will actually show you the path. So what the one we're looking at is a 23 network here, okay? And like I said, the next hop is 10.0.0.2, which is this one up here. It's going through the top route. And if we look here, if you read from right to left, it's actually telling you the path. It's originating in AS23, it's going to 44, and it's going to 100. Okay, so eBGP is effectively stamping every time you're moving from AS to AS, and it's counting that. So what we need to do is, this ISP is advertising that to us, saying, okay, it's went from 23 to 44 to 100, now it's in our local one here. This one is going to say, from this point of view, it's going to say it's stamped 23, 44, 66, 100. Now this has got 4 hops effectively, 4 ASs, and this has got 3. What we're going to do is effectively prepend, which is going to be adding in additional stamps to make the path synthetically longer than it really is. So what we're going to do is, from this point of view up here, we're going to make this one longer. We're going to leave this as it is, 23, 44, 66, 100, but what we're going to do is do 23, 44, 100, and when this one sends it to this router here, it's going to stamp it 100 multiple times. So when it counts the AS path, it's going to think this is a longer path and know that we're trying to influence to say, do you know what, discourage going across this link, this is longer, we're artificially making it longer, and prefer going down this path. And that's how we're going to actually affect change in a different AS. We're going to try to influence it by doing that. So let's just go in and just check the actual path it's taken. So if we first ping 23, 23, 23, 23, and we have reachability, and let's trace, and like I say, we should be going through the top link over AS. There we go. 10.0.0.2, 100.0.0.2, 44.0.0.2, and then 250.0.0.2. That's that one there. So what we're going to do is we're going to go into router 4. We're going to make all paths, because the only reason I'm doing this, you could just use a prefix list if you wanted and identify that particular prefix or range of prefixes. And this one, because that's what we did in the last one, we're going to actually just specify that all routes advertised from here to here are going to have this artificially extended AS path so as to discourage routing across this link. So the way we're going to do that is we're going to go in and create a route map. So we'll do route, move this over a wee bit, route map, and we'll just call it map, and we'll permit 10, that's the sequence list, just like an access control list. And we're going to do set AS path, and we're going to prepend it. So rather than send it, it's going to prepend and put 100, 100. So we're going to add 2 additional stamps to the list. So it's going to go 23, 44, 100, 100, 100, and that's going to actually have 5 hops rather than the 4. So it's going to therefore prefer down here. So we do that, and we exit, and again, so as we're not just filtering, we're going to just good practice to do that. Now, here's the thing, from the last video, we were doing, from our point of view of our AS, and we were saying from traffic sent to us, we're going to affect the local preference, so things which are being sent to us inbound. We are acting as ISP and we're sending it to someone else. So we're advertising the traffic, and that means the traffic is coming into us, so we're actually sending it outbound. We're saying traffic we are sending outbound, we want to affect it from our end. We're not taking it here and receiving it, we are sending it as we're putting it out. So what we need to do is make sure we attach it to the neighbour with the outbound command. So we go into router BGP 100, and we're going to make this neighbour here, which is going to be 100.0.0.1, and going to attach that route map on the outbound. So let's do that now then. The neighbour 100.0.0.1 route map, and it's map out. Just do a show route map. Yep, so that seems fine. And what we'll do is we'll just do a clear IP BGP soft. And we'll do that here as well, actually, just for good measure. Or rather, so we do a show IP BGP. Let's see if we've changed that. So now if we can see that the next hop for that route is now going to 10.0.0.6. It's now preferring that way and saying that the path we're preferring is 23, 44, 66, 100, because that's now 4 hops, and the one we've prepended was going to go 23, 44, 100, 100, 100, which is going to be 5. So it's now preferring the path there. So if we do the same thing, still have reachability, you see, and we're going to actually check the path we take. So we're going to trace it to 23, and if we look here, it's actually going 10.0.0.6 this way, 100.0.0.5, 66.0.0.2, we're going to the 66 AS this time, and then up here and here. So effectively what we're using is we're using the ESS path to basically influence the external AS we're using to say, listen, this is the one we prefer. We're giving them a kind of a hint to say, listen, we prefer this path here, even though you might think it's that one, we prefer that here. So what I'm going to do now is I'm going to add in another actual route. So we'll do int loopback 1 this time, and we'll add in the 99. And we'll do router BGP 23 and do network and put it into BGP. Oh, put the mask in. Pull that down. I really should have done that soft rather than a full one, but never mind. So effectively what we're going to do is, we have said, because we didn't specify an actual prefix, we've pretty much said we're prepending everything from this one to this link here. So we're going to discourage all networks being advertised through here. However, we're going to do a little bit of flexibility, and for this new link, we're going to say we're actually going to prefer the top link for that one and add even more path prepends. We're going to do path prepend 100, 100 on this one, which is going to have 100, 100 plus the 66, 44 and 23. That means that for all networks, we're going to prefer the bottom route. However, for this new 99, that one exception, we're going to prefer it over this. But the ISP, we're just saying we want that. So let's go and do that now and see if we've got that route here. So we do a show IP route, and we have that. So we do a show IP BGP, and like I say, it should still be preferring the bottom path at this point in time, because like I say, everything that this is one is advertising is being advertised with these two prepended ASs of 100, 100. So we're still preferring down here, and I'll just demonstrate that. So all the things we advertise is preferring the bottom path right now, which is the same. So what we're going to do is we're going to go into this router here, create a prefix list just for that actual prefix of the 99s, and additionally prepend that path. So with the ISP again, just for the sake of it, we're saying for this particular network we want a different route for this one. If you're going to go to this particular website or whatever, blah de blah. So we'll do an IP prefix list, and we'll just call it list, and we'll do permit 9999, and we'll do a /32, and we'll do a route map, and we'll just call this one again map, and the permit is a sequence of 10, and we're going to match the IP address that's in the prefix list called list, which is effectively matching 999999. And what we're going to do is set the AS path. I'm going to prepend that as well and put 100, 100. You could put even more if you wanted in, but I'm just going to put in, just say 3, whatever. And we'll do a route map, map permit 20, and exit out that. Okay, so now what we need to do is again, when we're advertising 99.99.99, we're going to prepend that with additional AS paths, and we're sending that outbound to this neighbor here. So again, it's an outbound one. So we're going to do router BGP 100, and we're going to do neighbor 105.0.0.1, and it's going to be route map and out, and we'll do a clear IP BGP. Oh, we really should have done the soft one again. I don't know why I keep forgetting to do that. And we'll let that come up. So we're going to discuss what's going to happen here. So like I say, all routes are going to be prepended from this point of view with 2 additional ASs of 100, 100. That's going to influence all the routes to go down this way. However, we've actually made an exception here for the actual route of 99, 99, 99, 99. We're going to put an additional prepended from this point of view just for that one route. So that one route will go this way. All other ones will go this way. After that, however, I'm going to show you that this is not actually, for example, from the point of view of AS5, AS5 still has control where it wants to send. These are just basically hints from the ISP saying this is what we would prefer. We'd prefer you to go this way, but like you see, you'll actually see there actually is a way to override that. You probably can guess just by looking at the right hand side, but we'll just show it in a wee second. So let's go and do, where were we? Show IP BGP. Okay, so that one is now preferring the top route again. So we do want to show IP BGP. Now we can see the path here for this one. The 99 one, this has got the initial path prepending, which is the 23, 44, 100 plus my additional 2. However, the bottom path for that one would be 23, 66, or 23, 44, 66, 100, 100, 100, which is actually, even though it's extended here, it still is shorter. So if we ping, or rather trace to the 99, now we're going to go through the top route again, and you can see that's true. We've went through 10.0.0.1, but again, if we try to trace to 23, we're still going to go through the bottom route, which is going to go through 66. We're missing out 66 in the first one. Okay, so that's the point of view of the ISP. The ISP is using AS paths, using that to prepend it because we can influence things within different autonomous systems. However, from the point of view of, let's say, let's go in here and we'll just say, you know what? From our network engineering point of view, we just like everything to go through this route here. We just want this as a backup. I know you prefer them to go through, rather, I've got that the wrong way around, because we changed it so that this one was generally preferred. Okay, so the ISP is trying to influence that most of our routes are going through here, this path. Now, we're going to say that actually we are receiving what you're telling us. We know you want to influence us to go through this way. However, we would much rather prefer we go through this way. Now, how could we do that? We could do that by using local preference, which again will propagate throughout our own AS, and it is more influential than AS path because it's higher up in the list. So if we went up to here and we said that we did a route map, and we just call this one John, and permit, and just set local preference to 200 and do a route map John, permit 20, exit, and do router BGP 5. And like I say, we're going to take it from all advertisements coming from 100.0.0.2 inbound this time, because it's sending it to us. So it's the stuff that's been sent to us we're trying to manipulate. So, and we're going to do route up map John inbound, clear IP BGP. Okay, so we're trying to effectively override that. So let's go and see if we've got a wee change here yet. Clear IP BGP soft, and do a show IP BGP. See, now our local preference is 200, and you look at all our next hops, are going through the top one. So even though the path prepended from the ISP, we're trying to say, listen, we prefer it over here from the local preference, which supersedes it. We're saying, no, actually, we would prefer it over this way though. So the ISP can use ES Path to influence because it does traverse multiple autonomous systems, whereas the ES Path is only local. So we couldn't do the local AS and send it out to affect this ISP. All we can do from this point of view is that we can send it here. So again, we will trace to 99, 99, 99. It's going to go through the top. Trace to the 23. That's going to go through the top as well, even despite the policies of the ISP. They're going to take the same route. Now, if we wanted to do the reverse, we could do the same thing and say, even though the ISP is wanting, the only one the ISP wants is the 99 to go over here. We're saying, no, we want everything over here, but we're going to be awkward. We just want the only one we want to go through this one is a 99. We can still override that and do a prefix list and just say IP prefix list rather list, and we'll do a permit of 99, 99, 99 /32 route map, and we'll just call this IPvZero permit 10. I'm going to match the IP address in the prefix list called list, and we're going to set the local preference to 250 and do a route map IPvZero permit 20, and we're going to do router BGP 5 neighbor 105.0.0.2 route map, and again it's going to be inbound because we're affecting routes being sent to us this time. And do a show IPv, or rather clear. Okay, so you see that. Let's just review this because this might be a bit confusing. The initial path was preferred to be the top. Now the ISP says we would prefer everything to go down the bottom link. The ISP then says, apart from the 99, we want that to go through the top. We're trying to influence you. Please send all your traffic through here, apart from the 99 to go through here. Just for the point of the video, I've been absolutely awkward and said, no, we want all the traffic to go through here, the top link, and exactly reverse of what you've asked me to. Rather than put the 99 over here, I'm putting the 99 over this link by using preference, because local preference, again, supersedes the AS path. So if we go to, like I say here, and we trace to the 99, our local preference is overriding it and we're sending it down the bottom path. So that is how AS path works. It just works by effectively stamping. Think of a stamp at the passport. The more stamps you get, the less desirable the route is, because it is seen to be a longer path, so to speak, in the eyes of BGP. And yep, that's pretty much the end of this video. Hopefully, like I say, this is going to be a wee bit confusing when you're first seeing this if you're not used to BGP. Again, as I do more and more videos, all these little things should hopefully become clearer and clearer. So if you just stick with it and stick through the series, then hopefully this will all become clear and it'll all work out good. Okie doke. So thanks very much, and I'll see you guys soon. Bye.